sample exam 3, 15 through 28, and number 18. Okay, we have two parametric equations. X of t is equal to t minus t squared, it says. Y is equal to square root of 2t plus 5. And ultimately we want to know the derivative at 2, so dy dx. Remember, in general we know dy dx is dy dt over dx dt. So knowing that, if we find the derivative of y here with respect to t, we write it as a power function. It's going to be derivative dy dt 1/2 times 2t plus 5 to the negative 1/2 times 2. Ultimately 2 and 1/2 will cancel out. We'll be left with 1 over square root of 2t plus 5. So that would be our dy dt. dx dt, of course, would be 1 minus 2t here. And either way, if we simplify this or not, regardless, we just need the derivative at a particular point here. So if we could put in our 2 in this stage, or we could simplify it, it's up to us, I guess. But bottom line is, if we put it in at this point, 2 in there would give us a square root of 9. 1 minus 2 times 2 down here. So we'd have 1/3 divided by negative 3. Or ultimately 1/3 times negative 1/3 would be negative 1/9. Which corresponds with letter C. That's what I said, right? Okay. So in a sense, it's ultimately a BC problem because it's parametric equations. Questions on any part of that one? What else? Ready? In 19, we got a list of values here, table of values for f and f of x, or f of x and f prime of x, I should say. And ultimately, we know that f is a differentiable function defined on interval negative 2 to 10, including negative 2 and 10, notice. And the table below gives the values of f and the derivative at several points. So, bottom line here is that it says the line tangent to the graph of f and parallel to the segment between the endpoints intersects the y-axis at the point what? So, ultimately, again, we're looking at a tangent line to the graph, okay, that is parallel to the segment between the endpoints. Ultimately, that in general is essentially like a mean value theorem problem. So slope between the endpoints and the tangent line have the same value. Okay. And so with that said, we could take our 2 points that are the endpoints here, negative 226 they gave us, and 10, 2, and we could calculate that slope between the endpoints. So ultimately, if we can develop an equation here for the derivative, then we hopefully can figure out where it crosses the y-axis, which is what they're after here. So if I do my 2 minus 26, my 10 minus negative 2, I get negative 14 on top and 12 on the bottom, so negative 7/6. I missed something. Oh, 24, sorry. That makes it even easier yet then. Good. Better yet, then work with 2 instead of a fraction. Nice. Alright, so if we get our negative 2 for our slope here, and again, keep in mind the line that we're talking about is tangent to the graph of f, and it's parallel to the segment between the endpoints. And so in terms of developing an equation for said line, we have one part of it done. We know the slope is negative 2. Now, the other thing we want to look at here is, in terms of this picture, again, if this was our picture, and again, this is just a generic picture here, not necessarily these points in question, but bottom line is, in order to be a tangent line, not only does the slope has to be the same as this slope, which we already accounted for, true? Okay, but it also has to be touching the curve, true? Alright, And if you look at the graph that we or if you look at the table that we have there, okay, what might be the giveaway as to where this connection is? In the bottom row, we have a list of derivatives, don't we? So at some point in that interval, okay, the derivative should be -2, shouldn't it? And where is that point where the derivative is -2? It's at 4/23, isn't it? So then therefore wouldn't 23 and 4 be our point in question? Okay. The derivative equals the slope between the endpoints at that point, doesn't it? And so with that, we'd have y minus 23 and -2x plus 8. We add 23, -2x plus 31. And ultimately the question was the line tangent, this line that we just written the equation for, intersects the y-axis at what point? So ultimately we're looking for the y-intercept, so it would be 0, 31, which corresponds with letter C that I just wrote. So 0, 31 would be letter C. What else? Ready? On 20, also just for the record on the previous one, that would be a AB problem. Working with tangent lines. And ultimately it's a mean value theorem problem. Uh, 20 we got says at each point xy on a certain curve, the slope of the curve is 4xy. The curve contains the point 0, 4. Then the equation is what? So ultimately we have we know that based on that given information that dy dx is 4xy. It told us that the derivative at a certain the slope of the curve is 4xy. All right, and ultimately it says the curve contains the point 0, 4, and we want to find the equation this came from. So ultimately, again, this is an AB problem, maybe. The only thing that would make it not an AB problem is if the antiderivatives were something that we needed to use, like integration by parts or some BC technique. Okay? But ultimately, it's an AB problem, like I said, maybe. And it turns out that once we see that when we do the separation of variables part, those are pretty easy antiderivatives, so it is an AB question. So we get natural log of absolute value of y. And here we get 2x squared plus c. So, from there, remember at that stage, as soon as we separate the variables and integrate, we'll find c. So we'll put in our initial condition, which is 0, 4. So we get ln 4 here, c here, so 0 in for x, we'll just give it c. And so at this stage, we'd have natural log of absolute value of y, and then 2x squared plus ln 4. And at this point, we need to find the, you get y by itself here, so we can compose both sides with e. If we compose both sides with e, remember we're composing the whole entire side with e. So therefore on the left hand side we'll get our y. And on the right hand side we'll get e to the 2x squared plus ln 4. But you'll notice that none of those are options because they expect us to do the algebra on this. And change the e to the 2x squared, e to the ln 4. Go backwards from our rules for multiplying two things with the same base. We add the exponents, so we can unadd them by rewriting it as such. And ultimately, what is that piece then? It's 4. So we did 4 times e to the 2x squared, which would correspond to, looks like, a. So just AB topic again, it's just a separable differential equation. What else? There. Okay. So going back to number 16, we got the graph of a function shown, and it says the graph. And keep in mind this is the graph of f. It's a differentiable function. Has a relative minimum at x equals 1, as we can see. Relative max at x equals 5. And again, the question here is let g be the function defined by g of x equals from 0 to x of f of t dt. And so our issue here is for what values of x does the graph of g change from concave up to concave down? Right? So keeping in mind that the graph of g is defined by the area here, and if we want to know something about g's concavity, then we need to know something about g's second derivative. So ultimately, if we want to find g's first derivative, if we use the fundamental theorem, we're going to get f of x, the integrand evaluated at the upper limit. And so g double prime, second derivative, is going to be the derivative of f. So ultimately, the values of g double prime are going to be based on the same thing as the values of the derivative of f, the picture that we see here. So bottom line is, the question is, for what values of x does g change from concave up to concave down? Well, if you look at the picture, ultimately, again, the derivative of f is going to tell us, okay, the derivative of f, the derivative is negative here, true? And then positive here, and then negative here. So if that's the case, that means the concavity of g will change at 1 and 5. And ultimately, we want to know, when does it change from concave up to concave down? Well, again, the derivative is negative. It goes from negative to positive. That means the g function would be concave down, then concave up. And it changes from concave up to concave down, would be at 5, which is letter D. So again, the values of the second derivative of g are the same as the values of the derivative of f. So when the derivative of f is positive, g prime is positive. It's concave up. Okay. So therefore the only choice there would be letter D. At 5 it would change from anything else in that group? How about next group, 21 to 25? And 21, we have the, just for the record here, that AB problem, F prime, F double prime relationships. We're going 1 over x squared minus 9 dx. And ultimately, if we have that as our integrand, we can see that u substitution won't do us any good because we'd have 2x dx. So there is no other x part here to get rid of with the to get du in here. So we should recognize that it's factorable though, and that if it's factorable, then we might be able to do integration by parts. Or I lied, partial fractions. So it's ultimately it's a BC topic, because partial fractions is BC. Alright, and if we do integration by parts, remember the issue here is we do b times x plus 3 plus a times x minus 3. Ultimately that would be the top of those two fractions if we were to add those two together. Those would be the two numerators. And we know added together they need to equal 1 to give us back to the integrand we started with. So we do bx plus 3b plus ax minus 3a. And we put the x's together, we'd have a plus b x plus 3b minus 3a equals 1. And again, we're equating the polynomial on the left with the polynomial on the right. So a plus b would have to equal 0 because there is no x term on the right. We know that 3a minus 3b would equal 1. That's the constant part. And ultimately, if we multiply these all by 3 and then add it together, we'd give 6a equals 1. So a would be 1/6. And if a is 1/6, that means that b is going to be negative 1/6. Yeah, we know that a plus b is equal to 0. Alright, so again, that does us good because we can rewrite the integral now as 1/6 over x plus 3 minus 1/6 over x minus 3. Put our a and b back in the spots that we created above, minus because that second one's negative. And if we integrate, we're going to wind up with 1/6. Take that right out. Natural log of x plus 3, absolute value, minus 1/6 natural log x minus 3, absolute value. And ultimately from there, the rest is algebra here. Of course, we have to have plus c on the end of that. Keep that in mind. But the rest of it is changing it, recognizing there's a 1/6, so we can take that out, and also recognizing that we have a logarithm of subtraction here. So that means we can write it as the division of the two arguments. So more compactly, so we wind up with letter D. Unless I missed something. No, I got this backwards.
You have 3A.
Yeah, what's this one? What am I looking at? Ah, I saw that. Now I got it. Thank you. So actually this winds up being a minus and that's a plus. That's why it's E not. So minus, plus, thank you. So B minus A, so ultimately we'd have flip that around, the A's would actually cancel out. So the 6B is, the B is the 1/6 and then the A would be the negative 1/6. So adjust that a little bit. Alright, so with that, once we change those also. Fix that accordingly. We did the negative one here. There's a negative one would be subtracting from their minus and the positive one, and therefore that one would be on top instead of the way I had it the first time. Alright. Questions on part of that one? Alright, others, 25? Jake? Yeah, let's see here. On 25, we have the we have a limit problem here of tangent of 2 times x plus h minus tangent of 2x over h, limit as h approaches 0. Keeping in mind that any limit here we could try to directly evaluate, but we're going to have an h on the bottom, which should be 0. Put in the 0, which is not going to work. So what we do want to recognize here is that ultimately this is the definition of a derivative, isn't it? So keep in mind that when we did the definition of a derivative on the top, we have the y values for the function. So ultimately when we do that, we put in x plus h and we put in x. So ultimately what is our y here? Just simply tangent 2x. And if that's the case, then we want to know what's the derivative of that. So we know that that's secant squared of 2x times 2. And so again, that's our derivative of said function, and we want to know the derivative at 0 it asks. So if we do at 0 here, we'd have secant squared of 0 times 2. And if we do secant at 0, remember is 1 over cosine 0. And ultimately cosine of 0 we know is 1. So we'd have 1 squared times 2 would be 2. And oh, look, I mixed up 2 problems there. We don't need to figure it out at any particular point, do we? So ultimately it was just this right here, isn't it? Yeah. Went too far. I mixed that up with number 24. I asked for the derivative at 0. So this one looks like it's D. So it's an A-B problem. Again, just make sure we know the definition of a derivative. Others, up 25? Ready? 22 says, which of the following definite integrals gives the length of the graph of y equals e to the x between 0 and 1? All right, so when we have a curve length problem, remember ultimately we're doing, it's an integral problem. It's one of our applications of integrals. Okay. And we can take a look at our definition in a minute, but remember what the general form is here, is that it's the integral from whatever we're going to in terms of x here from 0 to 1. And as long as the function is y in terms of x, then it's going to be 1 plus the derivative dy dx squared dx. And ultimately, bottom line here is that to get the simplified answer correct here in terms of our function, we need to actually figure out what is the derivative here. Well, y is e to the x. So e to the x. The derivative there then would be, again, the derivative of any e to the u function is itself. So e to the x times the derivative of the argument e to the x. So we'd have e to the x. Fair enough? So keep in mind that we could write that more compactly as e to the x plus x would be our derivative. True? So if that's our derivative and we put it into our function here, and we do e to the x plus x all squared dx, we'd wind up with 0 to 1. And if we square this, we got a power to a power situation. So what we do is multiply the powers. All right, keep in mind if I do e to the x plus x times 2, if I just did that over here somewhere, make sure we don't get confused on the powers. Remember, we're multiplying the power times the power, so it's just a distributive property problem. It'll be 2e to the x plus 2x. And ultimately, looks like that matches up with A. So ultimately, this is a. Can't remember if I have to look. I think I've seen a curve length on an AB before. Curve length is definitely part of BC because we did it in the other form also. Pretty sure it wouldn't be on the AB test, but I don't believe I can't try to remember if I'd ever seen a curve length one on the AB test, but not. So I'm thinking not. All right, others 25. How about 26 through 28? Sounds good. All right, so last part here, 26 to 28. We got a volume problem here. This is the base of the base of a solid is in the region, the first quadrant, bounded by the line given, x plus 2y, and the coordinate axes. So let's establish what that looks like first here. If we draw a graph of this, we could rewrite that as ultimately it would be negative x plus 4 all over 2. So negative 1/2 x plus 2. Down 1 over 2. Down 1 over 2. So ultimately that would be our shape 1, 2, 3, 4. Our intercepts here would be 4, 0, and 0, 2. So that's our shape of the region in question. And it says, what's the volume of a solid if every cross-section perpendicular to the x-axis is a semicircle? So ultimately, if we were to draw a slice here that was vertical, they were saying that it's going to come out at us as a semicircle. Okay. So we got to visualize that three-dimensional slice that we make as coming out of the paper at us as a semicircle. Okay. And so bottom line is, if we can see that 0 to 4 is going to be the integral, right? That'll sum up the volumes of each of these semicircles. And we know that a semicircle in general has a formula for volume of pi r squared h. And ultimately it'd be a half of that. So 1/2 pi r squared h, because it's a semicircle instead of a whole disk, if you will. Okay. Right, so the issue is, can we come up with an expression here that would give us the volume our semicircle in this case? Well, keep in mind the semicircle I drew, okay, the radius of it, keep in mind that this function here is y equals negative 1/2 x plus 2. Okay, so what would be the radius of this semicircle? It'd be half of that, wouldn't it? It'd be half of y here. So ultimately we'd have negative 1/4 x plus 1. Yeah, because it would be half of that y value that we see there on our semicircle. And then the h is the thickness, which ultimately the thickness is change in x, which when we write it as an integral, I'd factor all this stuff out, half pi out here, negative 1/4 x plus 1 squared dx. Alright, so once we have that, then again we just have an integral that we need to calculate, and it's a power function. So I'd expand that integrand and just use the power rule. That would do. Come up with the right answer here. If we expand that, we're gonna get negative 1/16 x squared minus a half x plus 1. So this will be our new integrand. Negative 1/16 x squared. If we expand that, and then the antiderivative. I do x cubed over 3. I'm gonna have negative x cubed over 48. X squared over 2 would be plus x squared over 4. Minus, sorry. And then plus x. And we're evaluating that from 0 to 4. Alright. Questions or problems so far? Alright, let's see if we can figure it out then. If we put our 4 in here, we're going to get 4 cubed, that's 64. So we'd have negative 64 over 48. If we put a 4 in here, we're going to get minus 16 over 4 plus 4. And that's it, because the 0 is going to, they all have x's in there, so zeros would make all the rest, the 0 would make all 3 of them 0. Alright, so let's see if we can figure out the culmination of all this. What do we got here with these two? We got 0 there, those two are both 4 and negative 4. And so ultimately we'd get, oh, you know what? This is positive. Got negative there 4. So, because we're squaring negative 1/4, so that should be positive 16, sorry. 64 over 48, multiplied by 2 would be 64 pi over 96. And ultimately it's our job to reduce at that point. And 16 can go into both of those. It'll be 4 and 6. Actually 32 can go into both of them, yeah. So 2 and 3, so 2 pi over 3. So that ends up being letter A. So ultimately an AB problem. So just volume of cross section. And remember the key element with working that problem is to make sure that we can look at one slice and be able to write the equation for the volume of that one slice. If we can do that, then it just becomes an integral when we sum up the volume of all the slices. What else? Jake? Okay, let's see here on 28, we have time measured in days greater than or equal to 0. We got a rate of growth for the bacteria population is given by y prime equals ky, and y is the number of bacteria present, k is a constant. The initial population is given 1500. It says the population is quadrupled during the first 2 days, and ultimately the question is by what factor would the population have increased during the first 3 days. Okay. So with this type of differential equation, there's a couple ways to proceed, but ultimately if we have our we try to do separation of variables like we did last time, we'd ultimately have 1 over y dy over here. This would be k dx over here. If we rewrote this as dy dx. Right? And so if we were to anti-differentiate, we'd have natural log of y, absolute value, and then we'd have kx plus c here. Alright, now what it boils down to is we could, with the given information that we have, again it says the initial population is 1500, right? So if that initial population is 1500, okay, and again it says it's quadrupled in 2 days, the x value here is actually our t value. In fact, I guess I'll change it to t. So we know that again the population is 1500, so if we did ln 1500, and that would be our c in this case. Remember time would be 0 at the initial if you will. So in terms of writing an equation, we'd wind up with lny, absolute value that is, equals kt plus ln 1500. Right? And the other thing that we know is that in 2 days it quadrupled. Right? So with that we could figure out what our k value is here, because we know that 2k plus ln 1500 would equal ln of 4500, or no, not 4500, 6000, quadrupled. And so again, we know a relationship here that involves time and population, and also k. And so if we subtracted, we'd have ln of 6000, ln 1500 equals 2k. Alright, and with that, if we divide it by 2 here, we would have our k. And ultimately, that, oh, you know what, you've done it. Nice algebra. Let's try that again. So ln 6000 minus ln 1500, 2k, which ultimately actually works out better because we can just deal with this now. That we got ln 600 minus ln 1500 would be ln of those two divided by each other. So ultimately we'd have ln 4 over here. And if we divided by 2, we'd have a half ln 4 equals k. And with that, we would have 4 to the 1/2. We put the power up top, or the outside part up as a power. Ultimately, we'd get ln 2 equals k. Alright. So, let's see. The culmination of all that then is our sentence now would read the natural log absolute value of y, ln 2t plus ln 1500 would be our equation. And with that, if we see, again, we know that the population went from 1500 to 6,000 in the first 2 days. So if we wanted to see if we can solve that, ln of 2t, ln 2 times t, and our time would be 3. You can see how much the population is at that point. So keeping in mind that these two right here would be ln 6, or no, actually here's where you have to be a little bit careful with our algebra. Don't multiply the 2 and the 3 together because the 2 is part of the ln argument. Okay, so we'd actually have ln 8 plus ln 1500, because we'd take that 3 and put it up top. Alright, and again, these two would be the multiplication of them, of each other, so 18, or 8 times 1500 should be 1500 times 8, 12,000. Alright, and all the while, we're trying to solve here for y, so if we compose both sides with e, we would just get that figure 12,000, and that would be our population after the 3rd day. And so bottom line is, the answer is not 12,000 because that's the population. We want to know it increased by a factor of what? Well, keep in mind it went from 1,500 to that 12,000 number. So what could we multiply 1,500 by to get that? It would be 8, wouldn't it? Okay. So therefore our factor would be 8, because if we do 12,000 divided by 1,500, we get our factor. Should be letter D. Alright. Questions on that one? Alright, ultimately here, I guess that would be an AB problem. So again, differential equation problem. Others?